Hello and welcome to today's session. This session focuses on learning outcome for LO4. Be able to write algorithms in popular programming languages. Are you ready to transform algorithmic ideas into practical code? In this video, we will explore how to write and implement algorithms using popular programming languages with a focus on both application and evaluation. You will also discover how pseudocode serves as a vital bridge between theoretical concepts and practical programming. Writing pseudocode is crucial for algorithmic implementation. It provides a universal template that can be translated into any programming language. Converting pseudocode into a routine involves understanding the essentials of the language. This includes if statements and loops. Jupyter notebooks offer a great environment for practicing these skills. Proving algorithm correctness requires formal methods like preconditions. Debugging helps detect errors during implementation. Timing algorithms is crucial for measuring performance. Jupyter Magic functions can assist in this process. These steps ensure the algorithm is both correct and efficient. Writing algorithms in practice involves several key steps. Define the problem clearly and select the right technique. Choose suitable data structures to implement logic. Use the language's syntax to ensure correctness and readability. A well-implemented algorithm scales well with input size. Algorithms rely on core constructs like sequence and selection. Iteration is vital for repetitive tasks using loops. These constructs are shared across popular languages like Python and Java. Understanding them forms the foundation of algorithmic logic. They ensure your code is efficient and easy to understand. Breaking algorithms into functions improves clarity. Functions allow recursion and parameter passing. They abstract complex algorithms into manageable parts. Understanding recursion and iteration is crucial. This knowledge helps in making informed implementation choices. Data structures like arrays and lists are central to algorithms. Stacks and queues offer specific advantages for certain tasks. Dictionaries and trees enhance data organization. The choice of structure influences algorithm performance. Built-in support in languages affects design choices. Different languages offer unique strengths. Python is known for readability and rapid development. Java emphasizes strong typing and object-oriented design. C and C++ provide low-level control. JavaScript excels in web-based environments. Despite differences, well-designed algorithms translate easily. Writing algorithms bridges theory and practice. It exposes performance and memory implications. Debugging and testing are supported by real implementations. This prepares you for real-world software tasks. A clear implementation enhances system performance. This outcome lays the foundation for specific algorithms. Sorting and searching are natural extensions. Recursion-based solutions become more approachable. Code evaluation for efficiency and readability is next. This prepares you for more advanced algorithmic challenges. Correct. Pseudocode is a language, independent way to design algorithms. It emphasizes logic and flow over syntax. This approach simplifies planning before coding. It aids in communicating ideas and identifying errors early. Pseudocode is precise yet simple, making it easy to read. Sequence, selection, and iteration are key elements. Instructions are executed in a defined order. Conditions decide between alternative actions. Loops repeat actions as needed. Variables store and manipulate data effectively. Define the problem and identify inputs and outputs. Break the problem into logical steps. Use control structures like conditions and loops. Maintain readability with indentation. This structured approach simplifies translation into code. Pseudocode serves as a template for coding. It separates logic from syntax, easing translation. Key principles guide conversion into languages like Python. Replace pseudocode keywords with language syntax. The logic remains unchanged while expression adapts. Pseudocode outlines the search logic clearly. Python implementation maps directly from pseudocode. The for loop and if statement mirror pseudocode structure. Input and output are managed through parameters and returns. This demonstrates the seamless transition from design to code. If statements handle decision-making, for loops iterate over known sequences, while loops repeat actions based on conditions. Functions package algorithms into reusable units. These constructs enhance clarity and testing. Jupyter Notebooks offer an interactive Python environment. Code runs in cells with immediate output below. Text, code, and results coexist in one document. This is ideal for experimenting with algorithms. Magic functions enhance workflow and performance analysis. Correctness ensures expected outputs for all valid inputs. Formal reasoning uses preconditions and postconditions. Loop invariants maintain correct state during iterations. These methods catch errors early and enhance confidence. Correctness proofs are vital in safety-critical systems. Debugging identifies and corrects implementation mistakes. Tools like IPDB help inspect program state. Debugging is systematic, not trial and error. It focuses on logical errors, the most challenging to detect. Effective debugging bridges intended and actual program behavior. Timing measures how long algorithms take to run. Jupyter's %timeit function provides accurate timing. Manual timing is useful when Jupyter is unavailable. Consider input size and memory usage alongside speed. Performance evaluation ensures algorithms are practical and efficient. In conclusion, this video has demonstrated how to write algorithms across popular programming languages. From the formulation of pseudocode to full implementation, each step plays a crucial role. Ensuring both correctness and efficiency is essential for producing practical and reliable solutions. By mastering these techniques, one can consistently develop optimized and effective algorithms. Any questions or concerns? Send a WhatsApp message to 0748 436 1688 and our team will gladly assist. Thank you, and see you next time.